And we are back. So now we will listen for the presentation, Lithuanian hate speech detection, why it is crucial for cybersecurity. One of the presenters is Danguolė Kalinauskaitė, is a language researcher with more than 8 years of experience in applications of language technologies. She holds a PhD in humanities, and her experience ranges from research in the fields of language technologies, social media discourse, narrative analysis, content analysis, to various R&D projects for different text generation tasks, hate speech recognition, phishing prevention, automated data personalization, etc. In her professional activities, Danguolė combines her research interests with business needs and has collaborated with different innovative R&D-oriented companies to solve real-life problems. She and her colleagues Milita Songailaitė and Eglė Kankevičiūtė will present their topic. And online hate speech is seen not only as a linguistic and social phenomenon, but also as a cyber threat with challenges faced by automated approaches for its identification. The presentation sheds light on a solution developed by Lithuanian researchers to reduce this threat, which can be used to monitor hateful content online for exploration of the phenomenon, as well as a preventive measure in making the online environment safer and more comfortable. So, ladies, the screen is yours, so please.
Okay, thank you. Okay, can you see the slides?
Yes, we see editing mode.
Okay.
And could you launch the full screen maybe? Yes, now we can see full screen, so please.
Okay, thank you. So hello, everyone. Today we're gonna talk about hate speech and its detection. We're gonna present what is achieved in Lithuanian automated hate speech identification, and we'll present a work by an interdisciplinary team of researchers from Vytautas Magnus University. And some of those researchers you can meet here. It's me and my colleagues Milita and Eglė. So I am a computational linguist. Milita and Eglė are machine learning specialists. So I will talk more about the concept of hate speech, what distinguishes it from other similar forms of negative content. And then Eglė and Milita will go deeper into technical details of our work. But first let's debunk some myths. One of which is that monitoring and detecting hate speech, treating, safeguarding freedom of speech, or are incompatible with it. There cannot be serious doubt that expressed hatred causes a harm. And this is what hate speech is all about. So countering hate speech respects freedom of expression. It only expresses intolerance to violence or hatred based on a person's immutable characteristics, ethnic background, and so on. Another similar myth tries to convince even more that hate speech prevention generally means nothing but online censorship. No, it is nothing more than a preventive measure in making the online environment safer and more comfortable for all of us, because hate speech is not equal to free speech. Actually, nobody tries to remove any content without significant reasons. So researchers are looking for solutions that can warn about possible cases of hate speech in order to help human content moderators who manually review content on their platforms and try to decide on whether it classifies as a hate speech or not. Need to be mentioned that speech targeting individuals is usually outside the scope of hate speech. However, in some cases, an individual can symbolize a group so that targeting that person becomes a form of hate speech against the group he represents. And therefore, it's not hate speech to say, I hate you without referring to a group. And this is where we should verify some facts. One of them is that also the phenomenon and itself is complex and non-trivial. It has very clear characteristics which helps to distinguish it from other types of negative content like toxic, aggressive, or offensive language. Sorry, something, okay, something wrong. Yeah. So what are those characteristics of hate speech? First of all, it has a target, specific group of individuals. And let's call such target the out group, which means that it has a defining characteristic that is different from haters' characteristics. And common dividing lines include race, ethnicity, religion, sexual orientation, gender, social status, and so on. Then hate speech expresses or promotes violence or hatred toward that specific group of individuals. It attacks or demeans individuals because they are members of a particular group. And it may have some kind of humor, such as sarcasm, which need to be mentioned, complicates its identification. And these characteristics form the basis for talking about hate speech as a cyber threat. Hate speech online is identified as one of the forms of cyber violence, and it can have a chain effect. So hateful messages can go viral in hours or even minutes. This means that the elements contained in hate speech, including manipulation techniques or rhetoric used to spread hate, can evolve and peak very quickly. Moreover, hate speech online can also be available for longer as compared to hate speech offline, and go through waves of popularity, connect with new networks, or reappear, as well as be anonymous. And all this forms the basis for various cybersecurity threats, including misinformation, disinformation, conspiracy theories, especially disinformation. Hate speech can be part of media disinformation campaigns, or in other words, fake news that are often abused by extremists to promote their ideas. And unfortunately, people can be quite easily persuaded of misinformation or disinformation. So this in turn can have wide offline consequences like exacerbated intolerance or discrimination towards particular groups, destabilize societies and political systems, not to mention hostility, violence, and consequences for the enjoyment of human rights for all. So all this negative context led us to experiment and researches of automated approaches, employing machine learning and deep learning techniques for identifying hateful content. Need to be mentioned that one of the main tasks for successful automatization of hate speech detection is data classification. For this task, we defined 3 categories that were used to classify all the data. So first of all, hate speech. It was the target category. Then offensive language worked as a test class to train models to identify actual instances of hate speech. And then non-hate speech was used as an intermediate or neutral category between the other 2. In some cases, hate speech can be confused with offensive speech. So here you can see some examples illustrating the differences between these 2. And yeah, so as we all understand, it is critical to recognize, monitor, collect data on and analyze hate speech trends in order to identify appropriate strategies to address them. And that's why solutions assisting in monitoring and detecting hateful content online for beta exploration are needed. And there is one of them, one of the solutions. But here I would like to give the screen to my colleagues, and they will provide you with more technical background of the solution. So Agla, please continue.
Okay, so thank you, Danguolė. And let's move to a more technical part of the hate speech recognition task. So those type of works usually starts from dataset creation. Next slide. Yeah, in this slide, you can see 4 main stages of creating a dataset. So first of all, you need to mine the data, or in other words, collect them from various resources, depend on the task you are doing. And the next step is you need to clean up the collected data. Then we need to annotate it. And after all, we are doing language pre-processing. And soon we will talk more about it. So in our case, for hate speech detection task, we selected most popular news portals in Lithuania, and there we collected comments from here. The main portals were 15 Minutes, Delphi, Alkas, El Rytas. Also, we collected comments from Facebook groups of relevant news portals. And you may ask how we do that. So we used Python programming language and some libraries inside of it, which allowed us to do that automatically. But sometimes the page structure are too difficult, or we wanted more specific comments. So we simply used our hands and searched what we need and collected the data. So after we have a collection of the comments, we had to clean up the data. So because sometimes when you're collecting the data automatically, especially, there could appear duplications, empty lines, or we can miss some data. So there you can see a data cleaning cycle. And the main steps of data cleaning is that, first of all, you need to import the different data collections, then you merge them because we needed one data set with our comments. And also then we rebuild missing data or cleaned up empty values. And also then we removed duplications. And after all, we had one clean data set with our comments. And after we clean up our data, it is very important step in classification task is to annotate every comment. So this step is important because we are teaching our model to understand 3 different classes, as Danguolė mentioned. It is hate speech, non-hate speech, and offensive speech. So for this work, we had 4 annotators, and we used the Docano software for data annotation. And as you can see in the pictures, it is really convenient open source software where you can simply go through every comment one by one and select a class for it. And the next and the last step was the text pre-processing. So where we had to remove punctuation from comments, unnecessary characters, also HTML tags, because when you do it automatically, sometimes it appears a lot of noise in the comments. And this stage is really important because computer can't understand text like a human. Because, for example, when we see some text surrounded by various symbols, we automatically skip them and read the main text as a human. And computers can't do that magical trick, so we need to do that job for the computer. So, of course, we had some challenges for pre-processing Lithuanian comments. So the first challenge is that some words that only Lithuanians could know or which we can call it barbarisms, is really useful in Lithuanian language. For example, we maybe Lithuanians know what is telefonas or like some valdžikė or something like those words, but the computer, for the computer is hard to say what that means. And the other problem is a context problem. For example, we have a command like fire them, so you could not know what to fire. It's just it's more context needed for that command. So we can't just choose the class very simply. And also the real problem is that Lithuanians also uses diacritics in their language, and also usually comments can be with incorrect writing. So this is a problem to a computer to understand better the language. And some people also tries to encode the hateful words by using emojis, numbers, or something like that. So that's all for problems. It's complicated for the computer to understand. So we annotated more than 25,000 comments. We did that by our hands. And what we found that in those comments who we collected, there was more than 15,000 comments in non-hate speech, more than 7,000 comments in offensive, and the last class was hate speech. We found that it is about more than 2,000 comments. So also what we tried to do did some visualizations, and we wanted to check what's the main topics in the comments, in Lithuanian comments, in news portals. So what we found that the main topics in hate speech, the first topic, it's about foreigners. It's there you can see some visualizations, which is called word clouds. So the first topic is about foreigners, Muslims, and other foreigners people. The second topic, and which was the most popular topic in the comments, was LGBT people. And the next slide, we can see topic 3, that it was about gender, which is also really common to spread hate. And the fourth topic was about Jews. And yeah, so that's about it from me. And Milita, stage is yours.
Okay, thank you, Egle. So the final part of also, Egle, can you mute your microphone? We're in the same room because of the echo. Okay, thank you. Yeah, so the final part of like our research, and the most important, actually not the most important, but for me at least the most interesting part of it was the actual detection of the hate speech. So for that we used artificial intelligence models, and the usual approach of creating a machine learning model is that we have a data set. We have some problem. We train the data set to solve, we train the model on the data set to solve that problem, and that's how we get one model who solves the specific task. In this case, we're using a bit different technology. It's called transfer learning. In this case, we have two data sets. One data set, it's like very broad. It's used to solve the source task. So in this case, since we were dealing with language, its task was to understand the Lithuanian language. And the second data set that we have, Egle already talked about it, it was the hate speech data set. So we took that model, which already understands Lithuanian language, and we trained that model to detect the hate speech. So after we have some model that already can, let's say, read texts in Lithuania, it was just a simple classification task to detect whether the comment is hate speech or not. The first
part of the model, like itself, how it works, was the embedding. So as we know, the sentence is made up of the words, and computers understand things in numbers. So we have to find a way how to convert that sentence into a sequence of the numbers. So there are like really simple ways. For example, you can just have a dictionary and mark for each word if one, like for example, one if there's like one word like that in our sentence, two if there are two words. Like the thing that's displayed in the slide. But nowadays problem required a bit more difficult solutions. So next slide. In this case, our embeddings had this specific attention thing, which let the model understand the context of a sentence as well. So for example, we can have two sentences. The first one is, we went to the river bank. And the second one is, I need to go to the bank to deposit money. In the first case and the second case, the bank word, the word is, we have the same word, but it has two different meanings. And if the model does not understand the context of a sentence, it cannot distinguish these two words. So that's what attention does. It reads everything around the sentence, and like the closest parts are the most important, the other parts are less important, but all of the words around it also does the impact to how the model understands the language. Next slide. So these models are usually called the transformer models, and that's what we used in our research, but maybe let's not stay here too long. So next slide. The two models that we actually used, three models. The first two were BERT models. We used a multilingual BERT model, which was trained on 104 languages, including Lithuanian language, and the other one was a bit more specific. Get back, a bit back. Yeah, previous, yeah, not so fast. And the other one was LitLatBERT. It was trained only on Lithuanian, Latvian, and English languages. We thought that it would be better since it has less languages in it. But the thing is that these two models, we have a lot of like words in them. We can understand a lot of words, especially the multilingual BERT, because it has so many languages, so it has more data and it's more likely to be accurate. However, the LitLatBERT has a bit less data, but it's like it has less languages, so it's more likely that it will understand those languages better also. And next slide. The final model that we used was the electrotransformer. In general, it performs a bit better with less data, so we decided to just train our own model from scratch, like the model that understands the language. And yeah, that's what we used it for, and we used 70 million words to train this model, like Lithuanian words. Okay, and let's move on. So the next task was to actually teach the models to classify the comments, and from this we can see that LitLatBERT did the best job. It had an overall accuracy 0.7. It means that on average 7 out of 10 comments are classified correctly. So those were the best results that we could get. And let's move on. So we had to test the model somewhere, and we couldn't do it on the comments that we had already because we wanted to see how it performs in some other real environment. So we chose a Telegram channel. We found a lot of questionable channels and we scraped the data from them. Overall we had almost 6,000 comments collected from them. Second slide. And these are the results. So we simply ran our models, ran our model through those comments, and that's what we got. As expected, most of the comments were not hate, because well, people, even if they write hateful things, like the chat has to go on, and only a small part of it is actually hateful, and that's what we also saw in our test. You can go on, and let's finalize everything. So we had to spend quite some time working with the hate speech, and just several results what we got overall. So it was very nice to have a Lithuanian language hate speech data set. It was really difficult to collect it and annotate it, and we're glad that we were able to create one. Also, that data set, we annotated some part of it, so now we actually have we can use train other models to classify the hate speech, because we already have the prepared data set. We also did our own approach in detecting hate speech. We tried 3 models. The best one we could get had 0.7 accuracy. And finally, we tested the best of our models in the Telegram. And we can now try to detect the hate speech. Hate speech in the comments of well, not only Telegram channels, but maybe other various channels. Okay, so that's it. Thank you. I guess it's the question time now.
Thank you for your presentation. It was nice that you presented your result, practical result, but also our audience would like to know that basically hate speech changes day by day usually. You did a lot of work by analyzing the data set, preparing it for the learning part. So how to react to the changes for new hate speech elements? For example, if you need to update your learning data and how much time it takes, how much is challenging for you? Could you briefly tell us?
Yeah, I think I can answer this question. So yes, actually the topics that people are discussing about also doing the hate speech about changes a lot during time. So if we want to update our models, we have to scrape again the data. We have to annotate it, and we have to retrain our models so that they could recognize the newer topics. It usually takes, well, the initial work, we did the initial work, so now it's going to take a bit less time. But in general, it still takes a lot of time because you actually have to annotate the data yourself, and that's the longest part of everything. Retraining models is not too much since we already have it prepared, but the annotations, it takes long.
It's challenging to collect everything and to manage it.
Yes.
And another question, in your opinion, what are some of the most effective ways to combat online hate speech and promote more civil discourse? How to make the world better?
Maybe I'm not the only one who can answer this question. Our approach was not, well, it was not to ban something from the news, social media websites or something. It was to warn the people that this might be hate speech. You should look into it. So I think the most, not sure if it's the most effective way, but the most humane way to do this is just to go through everything and maybe warn people that, well, this could be wrong, this could be bad, or something like that. You shouldn't talk like that.
To lift up social awareness, I suppose.
Yeah.
Or I would say that from our side, what we can do is to improve our solution, for example, in order to help those people who review all the content on their platforms. So yeah, this is the best way from our side, I think, from the researchers.
Okay, I see. Thank you for your answers and also for the presentation. Thank you very much. And we are preparing for our next presentation.